Hello dear students, this is Dr. Sourav Sir's class. We are solving some previous year questions from the subject is statistics. So now the question is telling us that the probability of getting a head in tossing of a coin is P, and P is belonging between 0 and 1. Okay, so the coin is independently tossed 25 times and head appears 10 times. Okay, so we have to, so we can say that, oh okay, the bias estimate of P with respect to the prior beta 5 okay, beta 5 comma 5, and the squared error loss function is, there are four options. So okay, so now we are tasked to solve the given problem. So we use the formula for the bias estimate under the squared error loss function. So the posterior distribution of P is determined by combining the prior beta 5 with the likelihood based on the observed data. So what can be done here? So firstly we have to think about the prior distribution, which is given as our beta alpha beta. So that can be my beta 5 comma 5, where my alpha is 5 and my beta is 5. So now the given data is what? So the coin is tossed 25 times and 10 times are observed. Sorry, the 10 times heads are observed. So now we can write that the number of heads, let it be x, be equals to, sorry, number of heads will be my 10, that is given in the question, and after that, so the number of tails will be what? That will be my n minus x. So my n is 25 because the coin is independently tossed 25 times. So the number of tails will be 15. So now we have to think about the posterior distribution. So when using the beta prior to a binomial likelihood, the posterior is also a beta distribution. So that can be look like my beta of alpha plus x comma beta plus n minus x will be my beta into alpha plus my x is 10. So that will be alpha plus 10, and that will be my beta plus n minus x, so that is 15. Okay, so as my alpha and beta are 15 there, so that can be my beta of 15 comma 20. So now we have to calculate the bias estimate. So Bayes estimate, yeah, so that can be what? So under the squared error loss function, the bias estimate is the mean of the posterior distribution. So mean of beta alpha beta will be what? That will be my alpha by alpha plus beta. So substituting alpha equals to 15, substituting alpha equals to 15 and my beta equals to 20, we get what? So the Bayes estimate will be 15 by 15 plus 20. So that will be 15 by 35. So we can cancel out by 5 and 5. So that will be my 3 by 7. So the Bayes estimate of P is 3 by 7. So what are my options? So my options are, okay. So our option A is the correct option of this question because that gives us 3 by 7. Hope you understood, guys. Thank you.